Children, once again welcome to our physics class. Hope you all are fine over there. Children, let's begin our new chapter, chapter 12, thermodynamics. In the previous chapter, we had discussed about the thermal properties of matter. In this chapter, we will discuss about the macroscopic properties such as heat, temperature, etc. So, thermodynamics is that branch of physics which deals with the concepts of heat and temperature and their relation to energy and work. We can also consider it as a macroscopic science which deals with bulk systems and tells us about the system as a whole. In this chapter, we will learn about the laws of thermodynamics, which describes the system in terms of macroscopic variables, reversible and irreversible processes. Finally, we will also learn on what principle heat engines, refrigerators and Carnot engine work. First concept that we are going to discuss in this chapter is thermal equilibrium. So what do you mean by thermal equilibrium? Two systems are said to be in thermal equilibrium if the temperatures of the two systems are equal. Okay, if you have two systems A and B, then if the temperatures of both the systems A and B are equal, both of them are said to be in thermal equilibrium. In mechanics, if the net force on a system is zero, the system is in equilibrium. In thermodynamics, equilibrium means all the macroscopic variables such as pressure, temperature and volume don't change with respect to time. They are constant throughout. So this is the difference between the concept of equilibrium in mechanics and thermodynamics. In mechanics, the system is said to be in equilibrium if the net force on the system is zero. But in thermodynamics, equilibrium means all the macroscopic variables such as pressure, temperature and volume must remain constant throughout. For example, consider two bodies at different temperatures. One is at 30 degrees Celsius and another at 60 degrees Celsius. Then the heat will flow from one body at higher temperature to the body at lower temperature, and this heat will flow till both the bodies acquire the same temperature. So here heat flows from a body at 60 degrees Celsius to the body at 30 degrees Celsius till the temperatures of both the bodies become equal. This state, after acquiring this state, there is no further heat flow. So this state, when there is no heat flow between two bodies, when they acquire the same temperature, is known as thermal equilibrium. Now what are the types of equilibrium? There are mainly three types of equilibrium. First one is thermal equilibrium. Two systems are said to be in thermal equilibrium with each other if the temperatures of both the systems do not change with respect to time. So temperature of both the systems should be constant in a thermal equilibrium. And what is chemical equilibrium? That is the another type of equilibrium. Two systems are said to be in chemical equilibrium with each other if the composition of the system does not change over time. That means if the components and all those things inside the system should not change with respect to time. And mechanical equilibrium is the third type of equilibrium. Two systems are said to be in mechanical equilibrium with each other if the pressure of the system does not change with respect to time. Okay, so the condition for mechanical equilibrium is that pressure of both the system should remain the same. And a system is said to be in thermodynamic equilibrium when all of its macroscopic variables are constant. That means if the system achieves all the above three equilibrium conditions, then the system is said to be in thermodynamic equilibrium. Then another concept that we want to discuss here is system. What do you mean by system? System is defined as any part of the universe enclosed by some boundary through which exchange of heat or energy takes place. So we are talking about the concept of system in thermodynamics. Okay, so system is defined as any part of the universe enclosed by some boundary through which exchange of heat or energy takes place. And what is surroundings? Any part of the universe which is not a system. Is it surrounding? So example, if we consider a hot coffee in a kettle, then the kettle is the system and everything else is the surroundings. So system and surroundings constitute universe. So kettle with hot coffee constitutes system here and everything else around it is surroundings. A system is in thermal equilibrium or not depends on the surroundings. For example, a cup of hot coffee after some time becomes cold due to the exchange of heat between the system and the surroundings. So the nature of the wall dividing the system and the surroundings is the another factor which determines the equilibrium condition. If the wall is adiabatic, then there will be no flow of heat between system and surroundings because adiabatic wall is an insulating wall. Heat does not flow through the adiabatic wall. So if the boundary between the system and the surrounding is an adiabatic wall, no heat flows occurs through that wall and it is an insulating wall. So there won't be any heat flow between the system and surroundings. On the other hand, if the wall separating the system and the surrounding is a diathermic wall, then the flow of heat will take place between the system and the surroundings because diathermic wall is a conducting wall. So two systems, whether they are in thermal equilibrium or not, that depends upon the wall separating the system and the surroundings and also depends upon the surroundings. Okay. Now different types of systems. So first one is open system. What do you mean by open system? See, in the system there is exchange of energy and matter. For example, water boils in a pan without lid, a cup of coffee. All these are examples for open systems because there is exchange of energy and matter. And the next type of system is closed system. In the system, exchange of matter does not take place, but exchange of energy takes place. For example, a balloon filled with gas, a pot with a lid. So if we consider a pot with a lid closed, in this case, heat is getting transferred from gas stove to pot and also heat is transferred to the surroundings. But steam is not allowed to escape from the pot. So exchange of energy exchange of energy takes place, but exchange of matter does not take place. Okay, so that is example for a closed system. Now another type of system is isolated system. In this system, there is neither change in matter nor change in energy. For example, any closed insulated vessel like thermos flask. In a thermos flask, tea can be kept hot for many hours because the walls of the thermos flask are insulated and it does not allow the heat to flow out of the flask. So such a system is an example for isolated system. Next we can discuss about the different types of walls surrounding the system and the surroundings. So we had already discussed about that. First one is adiabatic wall. Adiabatic wall is an insulating wall, means there is no exchange of heat. Okay, so it is an insulating wall which doesn't allow heat to flow from one system to another. This means temperature of both the system won't change with respect to time. So here you can consider two systems A and B, and this is separated by adiabatic wall, and heat does not flow from A to B. Similarly, heat cannot flow from B to A. So the temperature of both the systems do not change with respect to time. And next type of wall is diathermic wall, and it is a conducting wall which allows the flow of heat between any two systems. So here we can consider two systems A and B. It is separated by a conducting wall. Heat can flow from A to B. Similarly, heat can also flow from B to A. With this, I am concluding today's session. Notes of the topic and YouTube video have been uploaded. Please go through it. We will meet in the next session. Till then, take care all of you. Stay home, stay safe. Thank you.